In calculus, differentiation is the process of finding the derivative, which simply tells us how a function changes, its rate of change, its slope, or how fast something is increasing or decreasing. To make this process easier, mathematicians develop a set of rules that allow us to differentiate functions quickly without going back to the long limit definition every time. In this video, we will walk through the most important differentiation rules that you'll use in almost every calculus problem. We begin with the basic rules, like the constant rule, where the derivative of any constant is 0, and the power rule, which allows us to differentiate expressions like x to the power of n easily by bringing down the exponent and reducing it by 1. And next, we will move to the operation rules such as the sum and difference rule, which let us differentiate each term separately, and the constant multiple rule, which let us pull out constants during differentiation. After that, we explore the more advanced tools, the product rule and quotient rule, which help us differentiate functions that are multiplied or divided. These rules follow specific formulas that ensure we correctly handle both parts of the expression. By the end of this video, you'll understand not just what these rules are about, but how they work together to make differentiation faster, simpler, and more intuitive. So let's begin our journey into the rules of differentiation, your essential toolkit for solving calculus problems efficiently. Constant rule. The constant rule states that the derivative of a constant function is 0. This is because a constant does not change and the derivative measures the rate of change. Now let's have an example. Our first example here is f of x is equals to 5, and since 5 is a constant number, therefore the derivative of f of x equals to 5 is equals to 0. Our next example is equals to f of x is equals to 500. And 500 is a constant. This means that the derivative of f of x equals to 500 is equals to 0. Our third example here is f of x equals to 999, and 999 is a constant, therefore the derivative of f of x equals to 999 is equals to 0. So to apply the constant rule, identify any term in the function that is a constant. Since a constant does not change with respect to the variable, its derivative is directly assigned as 0. No further steps or transformations are required. Power rule. The power rule provides a method for differentiating functions in the form of x to the power of n, where n is a real number. It states that the derivative of x to the power of n is obtained by multiplying by the exponent and reducing the exponent by 1. Now let's have an example. Our first example is f of x is equals to x to the power of 2, or x squared. To simplify this, we will bring down the value of the exponent n and multiply it to the coefficient. Next is we will subtract 1 from the exponent, or as n minus 1. Let's simplify. 2 times x is equals to 2x and 2 minus 1 is equals to 1. Therefore, the derivative of f of x equals x squared is equals to 2x. Our next example is f of x equals to x to the power of 5. To simplify this, we will bring down the value of the exponent n, which is 5, and multiply it to the coefficient, wherein the coefficient is x, and we will subtract 1 from the exponent, or as n minus 1, this will be 5 minus 1. So 5 times x is simply 5x, and 5 minus 1 is equals to 4. Therefore, the derivative of f of x equals to x to the power of 5 is 5x to the power of 4. Now let's have our third example, which is f of x is equals to x to the power of 10. To answer this, we will bring down the value of the exponent n, which is 10, and multiply it to the coefficient, wherein the coefficient is x. And we will subtract 1 from the exponent, or as n minus 1, this will be 10 minus 1. 10 times x is simply 10x, and 10 minus 1 is equals to 9. Therefore, the derivative of the function x to the power of 10 is 10x to the power of 9. Let's keep in mind to use the power rule. Take the exponent of the term x to the power of n and multiply it by the coefficient. Then reduce the exponent by 1. This process is repeated for every term involving a power of x. Constant multiple rule. The constant multiple rule states that the derivative of a constant multiplied by a function is equal to the constant multiplied by the derivative of the function. This allows constants to be factored out during differentiation. Now let's apply this to the examples. Example number 1. F of x is equals to 2x. Here, the constant is 2 and the variable part is x. Using the rule, we multiply the constant by the derivative of x. Let's write the constant 2 and the derivative of x is 1 and x to the power of 1 minus 1. Now let's simplify. This will give us 2 times 1 equals 2. And x to the power of 1 minus 1 or 0 is 1. So 2 times 1 is equals to 2. Therefore, the derivative of the function 2x is equals to 2. Now let's move to another example, which is f of x is equals to 3x to the power of 5. Here, the constant is 3 and the variable part is x to the power of 5. We keep the constant and apply the power rule to x to the power of 5. So this will be x to the power of 5 minus 1. And let's simplify. This will be 3 times 5x and 5 minus 1 is equals to 4. Simplify further, this will be 15x to the power of 4. Therefore, the derivative of the function is 15x to the power of 4. Now, let's move to our last example, which is f of x is equals to 5x to the power of 9. Again, 5 is the constant and x to the power of 9 is the variable part. Let's apply the rule. So, this will become 5 times 9x and 9 minus 1. Let's simplify. This will give us 5 times 9x and 9 minus 1 is equals to 8. Let's simplify further. This will give us 45x to the power of 8. Therefore, the derivative of the function is 45x to the power of 8. In all these examples, the process is the same. Keep the constant, then differentiate the variable part. That is how the constant multiple rule works. Sum and difference rule. The sum and difference rule states that the derivative of a sum or difference of functions is equal to the sum or difference of the derivatives. This rule allows each term to be differentiated independently. Now let's have our first example, which is f of x is equals to x squared plus x. To simplify this, we will get the derivatives of each term. The derivative of x squared is simply 2x to the power of 1 minus 1 by applying the power rule. And the derivative of x is equals to 1. And simplify further, this will give us 2x to the power of 1 plus 1, which is 2x plus 1. Therefore, the derivative of the function x squared plus x is equals to 2x plus 1. Our next example is f of x is equals to 3x to the power of 4 plus 7x squared minus x. Now let's get the derivative of each term. The derivative of 3x to the power of 4 is 4 times 3x to the power of 4 minus 1, which is the power rule, and the derivative of 7x squared is 7x to the power of 2 minus 1, again using the power rule, and the derivative of negative x is negative 1. Simplify further, this will give us 4 times 3x and 4 minus 1 is equals to 3 plus 2 7x, and 2 minus 1 is simply 1, and bring down negative 1. Simplify further, this will give us 12x cubed plus 14x minus 1. Therefore, the derivative of the function is 12x cubed plus 14x minus 1. Now for our third example, our function is given as f of x is equals to x to the power of 5 minus x cubed. To answer this, let's get the derivative of each term. The derivative of x to the power of 5 is 5x to the power of 5 minus 1 by applying the power rule, and the derivative of x cubed is 3x to the power of 3 minus 1 by applying power rule. And simplify, this will give us 5x, 5 minus 1 is equals to 4, and 3x, 3 minus 1 is equals to 2. Therefore, the derivative of the function is 5x to the power of 4 minus 3x squared. Let's keep in mind to apply this rule, separate the function into individual terms based on addition or subtraction. Differentiate each term independently using the appropriate differentiation rules. Afterward, combine the derivatives by maintaining the original addition or subtraction signs. Product rule. The product rule is used when differentiating the product of two functions, and the formula of this rule is given by the derivative of the function is equals to the derivative of the function f times the function g plus the function f times the derivative of the function g. Now let's have our first example, which is y is equals to x squared times x cubed. And now let's identify our f of x, which is x squared. The derivative of f of x is equals to 2x. Our g of x is equals to x cubed. And the derivative of g of x is equals to 3x squared. Now let's substitute these values into the formula, which is the derivative of f of x times the g of x plus the derivative of g of x times f of x. And let's simplify. 2x times x cubed is equals to 2x to the power of 4 plus 3x squared times x squared is equals to 3x to the power of 4. Now let's combine like terms. 2x to the power of 4 plus 3x to the power of 4 is equals to 5x to the power of 4. Therefore, the derivative of the function is 5x to the power of 4. Now let's have our next example, which is y is equals to x cubed plus 2 times x squared minus 1. And let's identify our f of x, which is x cubed plus 2. The derivative of f of x is equals to 3x squared. Our g of x is equals to x squared minus 1. And the derivative of g of x is equals to 2x. Now let's substitute these values into the formula. Now let's simplify. 3x squared times x squared is equals to 3x to the power of 4. And 3x squared times negative 1 is equals to negative 3x squared. Plus 2x times x cubed is equals to 2x to the power of 4. Plus 2x times 2 is equals to 4x. And now let's combine like terms. 3x to the power of 4 plus 2x to the power of 4 is equals to 5x to the power of 4 minus 3x squared plus 4x. Therefore, the derivative of the function is 5x to the power of 4 minus 3x squared plus 4x. x. Keep in mind, to use the product rule, identify the two functions being multiplied. Differentiate the first function and multiply it by the second, then differentiate the second function and multiply it by the first. Add these two products to obtain the derivative of the entire expression. Quotient rule. The quotient rule is applied when differentiating a function expressed as a ratio of two differentiable functions, where the formula is the function or the derivative of the function is equals to the derivative of the function f times the function g minus function f times the derivative of function g over the square root of function g. Now let's have an example. Our first example is y is equals to x squared over x, and our f of x is x squared, and the derivative of f of x is equals to 2x. Now let's find what is our g of x. Our g of x is x, and the derivative of g of x is equals to 1. Now let's substitute these values into the quotient rule or the formula of the quotient rule. Now let's simplify. 2x times x is equals to 2x squared, and negative 1 times x squared is equals to negative x squared over x squared. Now let's simplify. 2x squared minus x squared is equals to x squared, and let's copy the denominator. So let's simplify further. This will give us x squared over x squared is simply 1. Therefore, the derivative of the function x squared over x is equals to 1. Example number 2. Y is equals to 3x cubed over x squared plus 1. Let's identify the values of f of x, derivative of f of x, g of x, and derivative of g of x. So f of x is equals to 3x cubed, and the derivative of f of x is equals to 9x squared. G of x is equals to x squared plus 1, and the derivative of g of x is equals to 2x. And let's simplify these values into the quotient rule formula. Now let's simplify. 9x squared times x squared is equals to 9x to the power 4. And 9x squared times 1 is equals to 9x squared. And negative 2x times 3x cubed is equals to 6x to the power 4 over x squared plus 1 squared. Let's combine like terms. 9x to the power 4 minus 6x to the power 4 is equals to 3x to the power of 4 plus 9x squared. And now let's factor the numerator, as the numerator is factorable by 3. Now let's factor out 3x squared. And 3x to the power of 4 divide 3x squared is equals to x squared. And 9x squared divide 3x squared is equals to 3. Therefore, the derivative of the function is 3x squared times x squared plus 3 over x squared plus 1 squared.